Continuing with this WMO report on climate services for health, what the state has been as of 2023, let's look at a bit more on what is known about what is known about the impacts of climate change on human health and what the IPCC says about future risks. I want to make sure I'm not putting too much noise from the fan here. Looks like I am. So when I record, it's very hot and humid, and in fact it would be nice to just do this without a shirt as if I'm on a beach, but that's not allowed. So it means I have to run a fan which makes a noise, and that produces some hissing sound in the recording if I'm not careful. So yeah, it's not so bad, I suppose. I'll check it anyway. Okay, so continuing with this, let's briefly say what I have completely covered the IPCC AR6 report in many podcasts, including this part on health that you can go and look up. Here briefly, the IPCC sixth assessment report, which came out in 21-22, COVID delayed it, has concluded that climate change is a multiplier of current health vulnerabilities, so it exacerbates many things, including food insecurity, limited access to safe water, and reduced access to improved sanitation, healthcare, and education. Table 1 highlights that climate change is predicted with very high confidence to increase global exposure to heat stress, and with high confidence to impact the transmission of infectious diseases and exposure to air pollution. You have to be very careful about these statements, because when they say it's predicted with high confidence to do this and that, it is done at a scale that you cannot, if a country cannot even use this information to say we are going to get this specific climate impact at this specific location so that we can do this specific thing. So we overstate sometimes how much information we are giving in terms of usable, actionable information, as we call it. Okay, so there are many other details, but as reported by the Lancet Countdown on Health and Climate Change, extreme heat is having devastating impacts globally in 2012 to 2021. Adults over 65 years, an age group that is particularly vulnerable to health impacts of extreme heat, experienced 3.1 billion more person days of heat waves annually. So that's 3.2 days per person in 2021 alone. So it has increased from 2012 to 2021 as well. This is compared to the baseline of 1986 to 2005. Driven by the rising temperatures and the growing over 65 population, so the population is aging, annual heat-related mortality in this age group increased by approximately 68% between 2017 and 2021 compared to 2000 to 2004 baseline. Worldwide heat exposure also limits labor capacity and productivity, undermining the livelihoods and well-being of families. Obviously, there are cascading effects, and we have to remember also that attributing mortality to heat is incredibly difficult, because heat tends to exacerbate a pre-existing condition, and the cause of death may not be heat when it actually happens. But this just increases the challenge to us climate scientists to produce early warnings at neighborhood scale so that people actually can be protected. Okay, the changing climatic conditions are also enhancing the transmission of many climatically sensitive infectious vector, food, and waterborne diseases. For example, dengue is the world's fastest spreading vector-borne disease. 2024 has seen an explosion as well. The suitable climatic conditions such as temperature and precipitation that are optimal for the proliferation of the mosquito vectors responsible for the transmission of dengue increased by 11.5% for the Aedes aegypti, which is the vector, and 12% for Aedes albopictus vector between 1951 to 1960 and 2012 to 2021. Meanwhile, the length of the malaria transmission season has increased in the highlands of Americas by 31.3% and of Africa by 13.8% over this period, adding extra pressure to disease control efforts, which we can look at here. So climate change impacts on health. 98 million people with moderate to severe food insecurity in 2020 than in previous 30 years. Malnutrition causes high vulnerability to climate impacts of health. Climate suitability of dengue transmission rose by 12% from 1951 to 60 to 2012 to 2021. Climate suitability of malaria transmission increased in the highlands of Americas and Africa by 31.3% and 13.8% respectively between 1951 to 1960 and 2012 to 2021. 7 million deaths globally in 2020 due to air pollution. Okay, that are premature deaths. All these have some methodology involved in how to attribute the deaths to particular causes. 470 million potential labor hours lost globally in 2021 due to heat waves, a 37% increase from 1990 to 1999. US dollar 669 billion, US dollar 669 billion potential loss on income in 2021. So when the economy gets hit, then maybe politicians pay more attention. Elderly and children were exposed to 3.2 more days of extreme heat per person in 2021 than annually in the previous 25 years. Heat-related deaths increased by 68% in 2017 to 2021 as compared to 2000 to 2004, keeping in mind that attributing deaths to heat is always tricky. Okay, so look at figure 2 here, which is again about projections. This figure 2 highlights that climate change is likely to present adverse and positive impacts on human systems and health in every world region. All of the human system impacts in figure 2 either affect health directly or are determinants of health and well-being. Okay, without reading too many details here, let's look at the table. This is the need for a systems approach, observed impacts of climate change on human systems. What is a systems approach? Basically, you have to look at all the linked components. Climate affects local weather, local extremes, which affects certain diseases, rainfall, vectors, pathogens, and socio-economic vulnerability based on income and facilities, disaster response. So it's a whole system in which the outcomes of health actually happen, and we have to have that systems approach. Confidence in attribution to climate change can be high, medium, or low based on these colors. Evidence can be limited or insufficient when it's empty circle, and sometimes they're not applicable. And impacts to increasing adverse impacts to human systems. Minus means increasing adverse impacts, plus minus means increasing adverse and positive impacts. So complicated because it depends on many factors like vulnerability, exposure, age groups, gender, etc. So income, per capita income, and of course income of the country itself, right? So impacts on water security and food production, impacts on health and well-being, impacts on cities, settlements, and infrastructure. Urban regions offer very specific challenges, and urbanization is growing, so this problem is going to get more and more challenging. So under impacts on water scarcity and food production, there is water scarcity, agriculture, crop production impacts, animal, livestock health and productivity. So whether the cow will give enough milk, a chicken will give enough eggs, or will it be enough protein or weight. Fisheries yields and aquaculture production. So I won't read all the pluses and minuses, but you are looking at human systems at global scale for Africa, Asia, human systems are going in this direction. Regions are going down here: Africa, Asia, Australasia, Central and South America, Europe, North America, small islands, Arctic, cities by the sea, coastal cities, Mediterranean region, and mountain regions. Under impact on health and well-being, we have infectious diseases, malnutrition, and other mental health and displacements, right? And impacts on cities, settlements, and infrastructure. We have inland flooding and associated dam ages, flood flood or storm-induced damages in coastal areas, damages to infrastructure like houses and bridges and hospitals or whatever else, damage to key economic sectors, could be finance, businesses, whatever else, right? So there are examples of vulnerable local groups across different contexts, including the following: indigenous people and of the Arctic, urban ethnic minorities who are more vulnerable in a city setting, smallholders, coffee producers, indigenous peoples in the Americas, older people, especially those poor and socially isolated, and island communities, children in rural low-income communities, people uprooted by conflict in the Near East and Sahel, women and non-binary, so sexual identification plays into social vulnerability, migrants, of course, Aboriginal and Torres Strait Islander population. Let me read it again. Aboriginal and Torres Strait Islander people living in informal settlements, which are basically slums and so on. Okay, so those are the stories. We'll come back and look at global distribution of vulnerable people with examples, which is this one, and here we are with observed human vulnerability to climate change as a key risk factor, and obviously it's region specific, location specific, and can be very different for rich countries and continents versus poor countries and continents. You can see even in Asia you have Afghanistan standing out here, in Africa you have Ghana here, maybe Cameroon, Nigeria, you have to figure out which country it is. In the Middle East you have countries without oil, maybe Yemen and so on. And you have here, what are the legends? Relative vulnerability being very high for reddish colors, high, medium, low and very low. Population density being high and low as well. So these are examples of indigenous people with high vulnerability to climate change and climate change responses as well. So lots of details there that I won't go into, but you get the point. When we say IPCC, or when IPCC claims it is providing very good predictions of how exposure to heat etc. will change, if you tell Afghanistan your heat exposure will increase, they can say okay, our older people will be more vulnerable, but will they protect all the vulnerable people? That will take so many resources. Can they get more specific information saying Kandahar will be the worst hit? Can they prioritize resources, because resources are always limited? So we need to keep on improving the location specific skillful information for actually driving decisions, and not just complain that decisions are not using climate information. Okay, so maybe that's long enough. We'll come back and look at health outcomes related to emissions and projected climate change attributable mortality. Again, projections themselves are highly uncertain. Attributing those to mortality will be even trickier, but we may have to keep going, trying to a country or a region has to look at this information and keep that in mind in terms of adaptation and building. For example, if a city is expected to become more vulnerable to heat, you want to increase green cover, you want to reduce emissions, you want to reduce congestion, you want to provide early warnings and increase access to hospitalization, hydration centers, shelters, people being able to take public transportation and so on and so forth. So there are many no regret decisions that can be made, but in the meantime we have to keep improving the information scales as well.